Okay, so now we're back for energy and ecosystems and a little bit more, part 2. In this, we're going to wrap up the concepts of energy flow through food webs and food chains and move on to the ecosystem's productivity concepts. I'm also going to put in a couple last comments at the end of this lecture that I had either forgotten to add into the previous lecture or things that I'm not actually going to lecture on, but things I'd like you to look at in your book. So, getting back to our other topics. This inefficient energy transfer that I went over in the first part of the lecture, shows the main reason why it is better to eat at a lower trophic level. If you eat at a lower trophic level, you get more energy. 2/3 of the human world population eats at a lower trophic level, meaning they eat mostly plants, vegetables, fruits, and grains. Mostly this is because they cannot afford meat. This is also the reason why there are very few food chains and food webs that have a 4th or a 5th level consumer. When you get up to that high of a level of consumers, there's not very much energy left, and so you can't sustain a very large population at that high of a level. All right, moving on to ecosystem productivity. Some ecosystems produce plant matter faster than others. The biomass a particular ecosystem can support is determined by the amount of energy captured and stored as chemical energy by producers in that ecosystem, and how fast the producers can produce and store that chemical energy. This means it's determined by the amount of photosynthesis the producers in that ecosystem can do, and how fast that photosynthesis can happen, and that the products of photosynthesis can be stored. Remember, we take and measure the energy in every single chemical bond that between every single atom used in the organisms that are producers to measure biomass. Now, we talk about ecosystem productivity in terms of gross primary productivity and net primary productivity. We're going to start with gross primary productivity, or GPP, for those people who are a fan of acronyms. So, gross primary productivity is the rate at which an ecosystem's producers convert solar energy into chemical energy as biomass found in their tissues. This means how fast or slow the producers, usually plants, convert solar energy through photosynthesis into chemical energy that is used to rearrange and create the tissues using the various elements gained from nutrients. This is measured in terms of energy production per unit area over a given time span. For example, kilocalories per square meter per year. So net primary productivity abbreviated to PROD here, also known as NPP, is the rate at which producers use photosynthesis to produce and store energy minus the rate at which they use that energy for their own respiration, for their own creation of tissues. So if you were to compare gross primary productivity and net primary productivity to families' income, gross primary productivity is the total amount of money that you make. Net primary productivity is the total amount of money that you make minus your living and working expenses. So minus the amount of money you spend on clothing, food, transportation, car maintenance, if you have a family, taking care of the other members of your family. So the equation for net primary productivity is net primary productivity equals GPP, or gross primary productivity, minus R, where R is the energy used in respiration. This measures how fast producers create energy that is actually usable by other organisms, generally the things that eat them. For those people who are a little confused at the idea of respiration, using the words that we were using before, respiration is the use of plants' own energy to create more biomass in the plant. So using the energy that they created to help themselves grow, help themselves continue to live. Now, if you look at the various different ecosystems and compare their average net primary productivity, there are a couple of trends that you see. In terrestrial ecosystems, the ecosystems that have the highest net primary productivity, I'm going to start calling it NPP from now on, are often located closer to the equator. As you move away from the equator towards the poles, the amount of sunlight and the concentration of sunlight decreases, and that directly impacts the ability of the producers to be able to photosynthesize. Now, if you look at the open ocean, it has one of the lowest average net NPPs around, with the exception of tundras, desert scrub, and extreme desert, which are all very harsh climates. However, even though the open ocean has the lowest average NPP, overall, for the planet, they are the largest primary producer of energy. And it's not because they're so great at it, it's just because there's so darn much open ocean. Now, this idea of being able to total up the entire planet's net primary productivity means that we can actually look at that and realize that it limits the number of consumers, including humans, that can survive on the planet. So this is something that we need to keep in mind when we're talking about various different areas and ecosystems productivity and how we as humans use the various different primary productivities of the ecosystems that we use and alter. So this is the end of the very last main concept for this set of lectures. I'm going to hold here for a moment, let you look at the chart. I'm going to come back with a couple comments that I want to make, and then give you the assignment for this set of lectures. Alright, so my quick comment. When we were talking about carnivores, omnivores, herbivores, we were talking about decomposers as well. And we had spent a lot of time talking about some of the larger organisms that act as detritus feeders, specifically things like vultures and hyenas. And I wanted to turn your attention to figure 310, which is on page 61 of my textbook, the teacher's edition. It's the picture that, if it's on a different page in your book, is the picture of the log going through the different stages of breaking down the log, and it shows your detritus feeders being mostly beetles, insects, termites, ants. And then as it gets broken down into smaller and smaller, simpler and simpler bits, you start seeing your actual decomposers, which are funguses and microbes. And I want to give a shout out to microbes and to our fungi and molds. Everybody thinks they're really gross, but they're actually really important to cycling nutrients through our world and getting it back down to that actual simple inorganic level. Most of the other decomposers only get it down to smaller and smaller types of organic compounds versus breaking it all the way back down to inorganics. So that was my main idea in that. I just wanted to make sure you guys knew what was going on with that and thought about that, because there's going to be a question on them in the assignment I'm about to give you. So this would be the assignment. I've added a list of questions that I want you to answer after listening to this segment on the Edmodo website. And by this segment, I mean both parts of the lecture. They will be due the day that I'm holding my lunch Q&A session on this lecture, and you'll find out what day that is on Monday. You can submit the assignment in one of three ways. You can hand in a physical copy, which is perfectly fine, or if you want to save paper, you can turn it in on Edmodo, or email an attached document to my Yeshiva email. Please do not write your answers in the body of the email. That makes it very hard to grade, and it's just a finicky personal preference of mine. So please, if you're going to email it to me, make sure you write it in a Word doc and send it to me as an attachment. I hope you guys have a wonderful weekend, / if you're reading this or listening to this during the school week, you've been having fun with our labs. Have a great day.